Hey everybody, I'm Miss D Love Boys and Girls Clubs of Greater St. Louis. I'm here today to have a little fun with you with a DIY in the science of sports. All right, today we're going to work on an experiment in kinesiology. We're going to have a little fun creating a simple machine. The experiment is to show you how the muscles in the arm works. And we're also going to see how dance and celebration in the sport of football explains kinesiology. Proper nutrition is one of the key components for success of sports. Athletes are routinely concerned about the foods that they put in their bodies. They work with nutritionists and coaches to develop healthy eating plans to stay in the best possible shape during the regular and off season. As players consume healthy foods, their bodies convert chemical energy in food to mechanical energy, which the body uses to fuel its muscles. What is kinesiology? Kinesiology is the study of the mechanics of body movements. Athletes' creative celebrations both allow them to express their individual creativity and reflect a number of complex body motions and scientific principles in the human anatomy. Dance and football both incorporate a range of scientific principles, including levers and motion. In a quarterback's throwing motion, the human body incorporates the simple machine, a lever, to build effort in the muscles of the arm. The elbow acts as a fulcrum, and the force is a contraction of the muscles in the arm to throw the football, while the football serves as the load that is thrown. The muscles and tendons of the arm use effort to work in concert with the fulcrum in the quarterback's arm to throw a pass to a receiver. The body uses a similar process when the player plants their foot into the ground to get ready to run. The toes are the fulcrum that bears the load of the leg and the foot, while the Achilles tendon and the calf muscle supply the effort needed to propel the runner forward. Now, before we get started with this DIY, here are the things that you need. All right, here are the materials that you're going to need to create your DIY simple machine. Make sure you have some notebook paper or notebook on hand because we're going to write some notes once we complete our simple machine. You need 3 paper towel rolls. Now, if you don't have paper towel rolls, don't worry. You can use cardboard or poster board and roll it up and tape the ends so that it looks like paper towel rolls. Also, jumbo paper clips, a permanent marker, masking tape, a tape measure or ruler. We're going to use science principles to create a replica of a simple machine in the human body. We're also going to analyze the simple machines used in a touchdown celebration. Okay, let's prepare our workspace. You're going to need first your permanent marker, your tape measure, or your ruler. We're going to measure 2 of the bones at 8 inches. And the third bone will be up to 12 inches. Typically, your paper towel roll, it's about 11 inches or 11.5 inches, but that's just fine. Next, after you mark 8 inches off one of your tubes, let's go ahead and get ready to cut it. It was a little tough, but I made do. Let's label our bones. Your two small bones are the radius and the ulna, and your large bone is called the humerus. After labeling our bones, we're going to move on to marking our pivot points. Your pivot point will be approximately a half inch from the edge. I'm marking all three bones with a pivot point on each one, because next what I have to do is poke a hole through each of those bones so that we can thread the paper clip through each one so that we can bind them together. You're going to have to straighten out your paper clip. It should be long enough. Just make sure you have the jumbo paper clips, because definitely a small paper clip won't help. A small paper clip would be too short. Now that we're finished measuring each section of the pivot point, we're going to thread the paper clip through all three bones. And once you get the paper clip through all three bones, we're going to close the end or fold the end of the paper clip so that it doesn't slide out. Next, go ahead and grab your masking tape. We are about to cover the paper clips. This will prevent injury, keep you from poking yourself, and also popping the balloon. And there you have it. Next, grab your long balloons. These are the balloons that clowns typically have to create balloon animals. I'm going to pick these two. I like the color orange, or this orange yellow. Put the rest away. And next we're going to blow up the balloons. Unfortunately, I couldn't actually blow these balloons up. It was really hard for me. So luckily I had this balloon pump, which enables me to go ahead and blow the balloons up without effort. All I have to do is pull back and push, and I would definitely get air in the balloon as I need it. So as we blow the balloons up, there is one important thing we have to do. We have to have space at the end and the beginning of the balloon. So I'm going to squeeze the balloon so I can let some air out, but keep the air in the middle. Each balloon will represent one of the muscles in our simple machine. Once I get the air to the middle of the balloon, I'm going to tie the end up. You don't want any air to escape. And we're going to do the second balloon the same way. Blow the balloon up. Make sure the air is in the middle. This probably would be a fun contest with your family to see who can blow the balloon up the fastest. Now that we have our bicep and tricep all ready, your two balloons are all blown up and tied up, we need to fasten the radius and ulna together. And what we're going to do is tape it. Again, grab your masking tape. We're going to tape the end of the radius and ulna, and that actually represents your wrist. Our elbow works. The pivot points in which we put the paper clips, that will be our elbow. Next, we need to tie our bicep to our simple machine. So don't do like I did. Make sure you pull that balloon a little bit further back, closer to the elbow, not so close to the wrist. Once you tie the bicep near the elbow, tie it at the top of the humerus bone. Grab your second balloon. This represents the tricep. You're going to tie it definitely closer to the elbow. And you're going to bring it around behind the humerus bone. And again, you're going to tie it at the top of the humerus bone. And that is the completion of your simple machine. You will use balloons and paper towel rolls to create a replica of the muscles and bones in the human body by creating your own simple machine. You can use the empty roll from paper towels. If you do not have access to paper towel rolls, you can also roll up a cardboard box or even poster board. You will roll that into a cylinder and hold it together with tape. Also, use a permanent marker, pen, or pencil to label the three major bones in the arm. Those major bones are humerus, radius, and ulna. Make sure you thread the paper clip through the radius, ulna, and humerus bones so all three are held together. Use a rubber band or tape to bind the other end of the radius and ulna together. This will represent the wrist. You will blow air into the long balloon and force the air into the center of the balloon, leaving the ends empty so they can be attached to the paper towel rolls. You will tie one of the loose ends of the balloon to the top of the humerus and the other end to the bottom of the radius and ulna. This will represent the bicep. Repeat the same process on the back of the cardboard rolls to create the triceps. Now flex and move your model to replicate how the arm moves as a lever in the human body. The positioning of the muscles and the bones here isn't precisely automatically correct. Your real flesh and blood arm is a lot more complicated. But let's test our model, discuss the results, and see what we can observe about the muscle action. Would this model work properly with only one balloon muscle? The answer is actually no. This is because skeletal muscles, like the ones in your arms, must work together in pairs. We call these pairs the flexor and the extensor. In this model, and in your own arm, the bicep is the flexor and the tricep is the extensor. I think I got it. I can't dance. I definitely can't do the salsa. Here's our final activity. We will discover physical science in our exploitation of simple machines in the human body. In this activity, we will learn to understand how muscles, joints, and tendons serve as levers and fulcrums. We will also explore how scientific principles of force and motion can be applied through motion and dance by analyzing how Victor Cruz's celebratory touchdown dance uses property of motion and simple machines. Use the chart to provide a description of the muscles that are necessary in Victor Cruz's salsa dance. If you like, you can grab a cell phone or a tablet or use another computer to take another look at Victor Cruz's touchdown salsa. Now reenact his body movements and use the chart to analyze the body movements involved in the dance. Finally, provide a written analysis in your notebook or on a sheet of paper of the body movements included in his touchdown celebration. You're going to use this chart. Take a look at it. You're going to provide a description of the muscles that are necessary in Victor Cruz's salsa dance. In the first column, you will see describe the touchdown dance or motions. In the second column, which simple machines are used in the celebration. And the third column, What muscle groups are involved in the operation of the simple machine in the human body? Now, you can draw this chart or you can just simply write down the question and your answer next to it, or just simply write down your answer. If you have any questions, please email them at gotquestions@bgcstl.org. Take a few seconds and view Victor Cruz's video. Watch his touchdown salsa. Be sure you use the chart to analyze the body movements involved in the dance. Okay, that concludes our DIY for today. I hope you all had a great time. I definitely did, trying to learn the moves of Victor Cruz. Not that great of a salsa dancer, but it was fun anyway. So until next time, play every day for at least 60 minutes. Eat healthy and have a great day.